Okay. Okay. So, I hope you can see my screen. Introduction to pandas. Hello, can you
Yes,
see
please.
my screen? Introduction
Yes,
to
please.
pandas.
Yes,
Daniel,
please.
please, what's up? Let
Yeah,
me know.
yeah, I can see.
Okay.
So please, your line is breaking. I can't hear you well.
Oh, that's so sorry. Can you all hear me well?
Yes, I can.
Yeah, I can
Can you
hear.
all hear me well?
Yeah.
Okay. Coming. Okay. I think in the group we over 50, but consistently only 20, 25 people have been joining anyway. Okay. Um, so introduction to pandas. So yesterday we looked at NumPy, n-dimensional or numerical Python for data manipulation. Now we are going to look at pandas, which you will use in every single day. Once you are going to work with data using Python, always import pandas as PD. Almost every time, import pandas as PD. So it's a one-dimensional labeled array. So we use it to hold any data type. It can hold strings, floats, anything at all. Okay. So we use it mainly for data manipulation, for data analysis, or we can say data exploration. Okay. So the syntax is import pandas as PD. It's a library already installed in Python. Or if you want to install it, if you are using a local computer, once you type pipe install pandas, it's going to also install pandas as well. Can you please hear me clearly now? Can you please hear me clearly?
Yes, please, you can hear clearly.
Yes, please, we can hear you
Uh,
clearly.
okay, sure. So now we continue. So the syntax is import pandas as PD. Then for the NumPy, as we said yesterday, is import NumPy as MP. So that is it. And then how do we do indexing in or using pandas? So as we can see, a data set which is named or a variable which is named as series is equal to PD, which is pandas.series. So the data set has 10, 20, and 30. And then we are indexing. So index is equals to A, B, and C. So automatically A matches to 10, B matches to 20, and C matches to 30. I hope you understand. So now whenever I call, let's say, an index A, automatically I'm expecting the output to be what? 10. I hope you get it. And then in the same vein, I can define the index, but if I don't define the index, the default index for 10 is 0, the default index for 20 is 1, and the default index for 30 is 2 from what we've done previously. Please, is this clear?
Yes, please.
Yes, please.
So now, what will be the output for this slicing? Print my series A to C. What will be the output? Can someone tell me based on what you've done so far? So come here and we have my underscore series equals to pd dot series.
30.
What did you say? Can you please come
10,
again?
20.
10, 20, and 30. Okay, let's see. If you use column or you just how do we call? Assume. I just want to know.
10:30.
Okay. So come on, just this PD. Sorry. I need to do this import pandas as PD. Okay. So you can see A is mapped to 1, B is mapped to 2, C is mapped to 3. Okay. So now back to that. So you mentioned 10 and 30, right? Uh,
Yes.
okay, let's see. So, okay, let me use actually the numbers so that it becomes okay for us. So, okay, so it's actually going to start from 10 and end at 30. So it's going to be 10, 20, 30. I hope that is fine.
Okay.
Okay, so this is it. So let's move on. So that is how we can also do indexing and slicing using pandas. Okay,
All right, sir.
and we move on to the data frame in pandas. So now, a data frame. Yesterday I mentioned something about data frame when we were using when we started looking at NumPy. So that one is two-dimensional labeled structure or data structure, which has columns, and the columns may have different types of variables. I hope you understand. So just like as we were looking in the Michael, I'll come to you. Let me finish this. You can keep your hands raised, so don't worry. So like just like in any data sheets or in any spreadsheets, the data can be of different forms. You get me? It can have the data can have names of people, ages of people, money, dots here and there, maybe a whole lot of different types of data. So that is basically how the data frames in pandas also stores data. It can have data of different types. Please, I hope that is fine. Just as you may see a data in Excel or in any spreadsheet. Okay.
All right.
Michael, please, I want to know what's up.
I think I got lost at the series operations. At some point it was 10, 20, 30, and then it became 1, 2, 3.
No, no. So I just changed the what do we call? I just changed it. It's the same concept. The numbers doesn't really matter. I hope you
Okay.
understand.
All
So the
right.
same concept that I was trying to explain, that once you put in a list and an index, automatically the first index is matched to the first value, the second index is matched to the
Okay.
second value, and so on. You get it?
All right. Yeah, thank you.
Okay. Okay. So in this context, okay, we are saying we define the data where it has dictionaries, okay? So column 1 is mapped to what? A set of, a list of variables. Column 2, another list of variables. Column 3, another list of variables. And now we need to store this data into a data frame so that we can just be using the data frame in subsequent analysis that we are going to do. So that is basically what the example is saying. So we are trying to create a dictionary of lists, so creating a data frame from a dictionary of list or NumPy arrays. So we can see yesterday we looked at dictionary. So I believe we know that this data is a dictionary with keys. How many keys do we have here? Can someone let me know the keys in this dictionary? Can someone let me know the keys in this dictionary?
No.
Can you
I
come
mean,
again, sir?
I mentioned yesterday we looked at dictionaries. Can someone let me know the keys in this dictionary? In the example, the data is equal to column 1, that's column 2, that's column 3, that's. Can you let me know?
I'm Richard. I think there are three keys.
There are three keys there.
Yeah, so let me know the keys. Which are the keys? I just want to know.
Okay, they
Column
those in the quote CLO1 is the key. Then the
Okay,
column is the value.
okay. Thank you very much. That is it. So the one in the quotes are the keys, and the other ones, the numbers or list of numbers are the values. Okay. So now we are looking at data wrangling. So, when you are working in the real world, the data is messy data. It is unstructured data. It's in rare cases that you will find structured data. If you find structured data, thank God. But most of the time, the data can be in a different form. And you need to clean the data into a particular form for you to be able to use the data for your intended purpose. I hope you understand me. We are going to get some data sets, and then you see how we can clean those data sets. So data wrangling is basically, or it involves data cleaning, transforming the data, raw data, into a more usable and valuable format. I hope you understand. Valuable format means format that you can use the data for your intended purpose. Okay, so these are the processes of data wrangling. One, discovery. When you get the data, you need to understand the data. What is the data about? How many rows? How many columns? You need to kind of understand what the data it's all about. Do you get it? And now, once you understand the data, first, you then structure the data. And for you to structure data, you should understand the domain context. Okay, it's a marketing data that I'm working with. What are the key things that I need in this data? The data can have like a lot of rows, a lot of columns of different headings. Maybe not all the headings may be necessary for the task you want to perform. So the domain knowledge here is very important to help you in structuring the data, to know the columns that are really necessary or really important and the columns that you need to do away with. And then now you now clean the data. The data some of them may have incomplete rows, incomplete columns. A whole lot. And then as we move on, I'll tell you how processes of handling missing data and how you can deal with those missing data. So you clean the data to remove all errors that may have impacts on your analysis. Do you get it? The errors in the data which may have impact or which will cause your analysis to be skewed or biased. You remove all those things. And then you enrich the data. Do you get it? So you determine whether to enrich or augment your existing data. That is, if you have already existing data, would you want to compare and contrast? Would you want to join those data to get a holistic view? All those things comes. And then verifying, you confirm that your data is consistent and high quality. Consistent means if it is floats, they are floats. If you want to work with floats, you are working with floats. If you want to work with strings, if you want to work with integers, so the data types are consistent throughout. The data formats are consistent throughout. There are no missing data here and there. I hope you understand. There is no missing column header. There is no missing row. There is nothing missing. Everything is consistent as you want. And now, publishing is basically assuming you are working as a data engineer, you make the data available to be used by the analyst and then the scientists and all those other people who would need your data to work. If you are working yourself as analyst, you go through this from scratch. In some companies, they may not have engineers to do all these things. So you need to do those works yourself. And now you can, what do we call? You can now work with the data. I hope that is clear. So these are the 6 steps of data wrangling. Okay. And now we come to data transformation. So the data transformation is, should I say, a subset of data cleaning or data wrangling. So for that one, you focus on how you convert data from one format or one structure to another. Data can be in a form of audio, data can be in a form of picture, and a whole lot. So there are tools you can use for this purpose, just as we are using Python. Python is a big programming language. It has several libraries. We have libraries like pandas, which we have looked at, NumPy, which we've looked at, skitlearn, which we will look at in the later part of the course when we are looking at introduction to machine learning. So, and it has a lot of other, it has a lot of other libraries that you can use. We have this softwares to open, refine, and that one, Trifactor Wrangler. There are a lot of softwares in this. I'm not saying these are the only software. There are lots, but these are just few. We have ETL tools too. ETL means extract, transform, and load. And we have ELT, extract, load, transform, depending on what you are doing. We have Apache Nify, Apache Kafka. These are much more data engineering tools. And then databases, you can also learn SQL for data manipulation. Yeah. So these are some of the tools, not all the tools, some of the tools for data transformation. Basically, working on the data to suit how you want the data to be or to suit your specifications. Do you have questions up to this point? Hello?
I think someone raised the sun.
Okay, we'll start.
I just want to ask this question.
Okay.
After the data wrangling, the steps. So when you want to do the data wrangling, all the steps that you have outlined are necessary to do.
Yes. Yes.
Yeah.
So yeah, once you are doing this automatically, whether by intuition or by default, you do all these things because you need to prepare your data before you can use it. I hope you understand.
Yes.
Thank you. Okay. So we are going to look at some of the techniques over here. Okay. Coming. This is to I'm just trying to see how uh, sorry. I'm just thinking if all these things can be consumed at this level. But then okay, so data type conversion. So that means we are basically converting from one type to another. Do you get it? So let's look at this example. So now in this example, okay, that you can see on the screen, the data is equal to, so one thing is when I share the slides to you, can actually type or code all these things in Colab just to see how they work. Okay, so the data is equal to this dictionary that we can see here. Okay, column 1 with this list, column 2 with that list. And then we store it in a data frame using pandas. Fine. Now that we've stored it into this data frame, we want to convert the column 1 to an integer type. Can someone tell me the type that we see here, the values for column 1? Can you tell me the data type over there? Can you let me know? I can't hear you. Yes, so it's a string. It's a string. It's a string because of the columns there, or should I say inverted commas? Yeah, it's the inverted commas. Sorry, not columns. The inverted commas there. You get me? So once, even though it's 1, 2, 3, but because of that thing, it's automatically a string. So now we want to convert it into an integer. Okay, that is why we are doing PD to numeric. And now we bring in, so the data frame we are looking at here, in this data, remember, let me explain this. This data frame is storing everything here. Okay, as you can see where my cursor is moving, everything here. Now here we are dealing with a specific thing in the data frame, or in this data stored in the data frame. That is why we need to define it here. Data frame, we introduce the square brackets and define that we are working with column 1. I hope you understand. Okay. And then equal to PD to numeric, that one, it doesn't mean it should be the same. Normally, when you are coding, you should use names that will make you understand, or that will, whenever you are going back through the work you've done, you can quickly remember what you've done. It doesn't mean it has to always be this. It can be any name that you want. I'm talking about the to underscore numeric. This is that clear? And then we bring this data frame here, and then we are just trying to coerce any error that will come. And then the filling will come later. We are going to look at that later. Sometimes this is whenever there is any missing or not available data, we then introduce 0 there. You get it. And as type is the as type is the conversion. We are converting it to what? Integer. And then the second one too, we are converting it to what? A float. So you need to define the data type that you want to convert the original type to. Please. Okay. So that is that example. Permit me to skip those parts because we are going to look at it when we are doing introduction to machine learning, okay? Because I'm coming, let me check something. Yeah, sure. So permit me to look at that. We are going to skip that. We are going to look at it when we are doing introduction to machine learning. However, I'll still share the slide so you can look at it. The skit-learn pre-processing and then the standard scaler. Yeah, we are going to look at it in the data cleaning parts, which we are going to go there very soon. But I just want us to skip this whole thing now. Now, basically, for you to understand what is here is, when you are training machine learning models, okay, the data can be very big data, one, and then the standard deviation, and it can be of different values. For you to get a very good predictive analytics or predictive analysis, you need to always scale your values between zeros and ones, or convert your values to zeros and ones. That way, the machine or the algorithm will be able to learn your data very well. So that is where we bring the minimum and the maximum scaling, the standard scaler, to scale whatever value between zeros and ones. I hope you understand. That is the purpose of the standard scaler. It can treat imbalances, which we may look at them later, and all those things. It's kind of, we are not actually going to go into details in that, but in the intermediate, we are looking at that one. So basically, that is another technique for data transformation. I hope you understand. So let me give you an example here. I hope this, you may not understand, but I just want to take you through. So in this, please, I hope you can see my screen. Yes, we can see.
Yes.
So yeah, both standardize and split data. So over here, before the standardization. So basically what I'm doing here is I'm coming. Okay. So you see this one, scalar is equal to standard scalar. So I'm just trying to convert the data into zeros and ones. Because when we look at the original data, okay, the original data, the sample here, did I even read? You can see, okay, you see we have 20, 30, 1 to 200 and something, all these things. So I want to convert all these things to zeros and ones. You get it? So that is the purpose of the standardization, so that our data can be within a particular range for us to have an efficiency for with our intended purpose. And this called standardization too is similar to what I mentioned, is to scale the data to have a mean of 0 and a standard deviation of 1. So everything between zeros and ones. Okay. Data aggregation. So with that one, sometimes, especially when you are working with SQL, using the joins, left join, right join, um, yeah, those different types of joins. Okay. So you can combine data from multiple rows and columns into a single row and column. Okay. So now, with this example that we are seeing here, we have a data set or a dictionary defined, okay, a category, and then its values and a value, and then that as well. And then now we are saying that group category, group by category, group by two is something in SQL, and not then calculate the sum of the value. So now, yes, then so the group by anyway. Let me try and then get. I'm coming. Hold on. Let me try and get the codes for this. Can you see my screen? Hello?
Yes,
Hello?
we
Hello?
can see.
Which which of my screens can you see? So I know.
The data
This is
transformation.
the data transformation.
Okay. Okay. Sure. I'm coming. Hold on. Okay. Okay. So I'm trying to get the codes for us to look at it. Okay. So can you see this? Can you see my collab now?
Yes, please.
Okay, so with the example that we're looking at, okay, so there's our sample data. So we have this data, we have column which has its categories and the value which has its, there's another column with the values, okay. And then we store this data into this data frame. Now we want to perform a data aggregation here. So the aggregated data is equal to df dot group by. So we are grouping everything. So now we are grouping by category. Okay, that is why it is here. And then the value, and then we sum the whole thing. Okay, so now look at this whole thing. So we are the reset index is just to kind of rename all the, give us a new index. So the zero is automatically zero. Zero is for A. You know, in this data set too, there are repetitions. Now we have A, A. I hope you understand. B, B, and then we have C as well. So it means automatically. So the values also match to the number of items here. We have 10, 5, 10, 15, 20, 25, 30. So what we are doing is we want to sum everything A as 1, sum everything B as 2, and sum everything C together. I hope you understand. That is why we are using the group by function. So we are going to group by the category, and then we get the values based on each category. So this is the output. So basically, when you add 10 and 15, you get 25. When you add 20 and 25, you get 45. And when you add 30, I mean, it's just C. So that appears here. Please, is this okay? And you know, you are right to you different, assume we are working on a customer data. One customer can buy multiple items. So assuming you are using customer ID, so you may see one customer ID has multiple items. So when you want to see maybe which customer their behavior, you need to go by the IDs and see the total purchase or their purchase pattern. I hope you understand. That is where these things are very important. Please, is that clear?
Yes, please.
Are we getting there, or I'm making you guys confused? Please let me know. I'm making you
We are there.
confused.
No.
Please feel free. Daniel, you can talk. Let me know what you want to say.
Please, wait, what you just showed us now, the data filtering. Please, you see, the aggregation, the A's are 2, the B's are 2, and the C is 1. Please, if
Someone is talking now, and someone is also making noise. Who is this? Oh, Daniel, is it your background? Daniel, I think it's your background. There are people around you who are.
Okay, please.
So you
the
can
first
ask your
one.
question.
Okay, please, if you want to go with the first one, now you see what you have given us, like it's combined the two A's. So please, if you want to go with the first one, the first A, and also maybe the last B, how would you get this done, please?
The first A and the last B. So basically, it wouldn't be possible because A is A. Okay. So we just want to perform an aggregation of sum in this particular context. Okay.
Okay, please.
Example that we are looking at is more or less they have the same ID. So it will be difficult for you to segregate because it's the same customer. But assume we had A1, A2, then that one we can segregate as you are talking about. Okay.
Okay, please. Okay, please. So,
Yeah.
thank you.
Sure. Or in another vein, assume there were years. That one too, we could have used the year, even though it's the same A, but we can use the year to differentiate. But in this case, there is nothing like that, so it will be difficult for us to do that. I don't know if that is okay for you.
Yes, please. Please, thank you.
Okay, thank you. So we are going to data filtering. So that one too, let me paste it here. Can you see my collab? Can you see the collab?
Yes, please, you can see.
Okay. So now, so data is equal to the same data. We are working with the same data. However, we want to filter the value. Maybe we have different customers, and then we are saying that, okay, we want to see customers who purchase, let's say, who maybe in the last month purchased more than 10 items. I hope you understand. So the filtered value, the data frame we are talking about is what? Value. Okay. Okay. I mean, as I mentioned, this whole thing is stored in the data frame, and we need to specify which of the dictionaries and keys in the dictionaries we are going to talk about or we are going to work with. That is why we specified value here. So Once we run this, anything that is greater than 15 should pop up. So we can see that that I hope it's clear. So anything now we are working with values. We are not working with category. So any value, so even if we have 20 Bs, and if the values are more than 15, all the 20 Bs will pop up. Please, I hope it's clear, because at this point, the focus is on which of them has more than a particular amount or a particular value. So that is also another way for you to kind of see how your data is looking like. Okay, so maybe if you are working with hospital data sets, what is the frequency of visits? Okay, maybe in the last month, you want to filter to see how many people visited more than twice. You do that, and then you'll be able to see the list of patients who might have visited the hospital more than twice in the last month or last week or whatever time frame you're looking at. Please, is that okay?
Yes, sir.
Are we enjoying, or if I started asking ourselves why we sign up? Are we enjoying, Sharon?
Yes, we are. We are.
Yes, sir.
Sharon, please, you can talk.
Yes. So please, can you go back to the collab page? I wanted to ask a question from that side.
Okay. Do you see the collab page now?
No.
Can you see it?
Yes. Okay. I wanted to ask. Yes, please. I wanted to ask what the 1, 3, and 4 stand for. Is it a frequency?
So this one stands for the, what do we call? Can someone, before I talk, can someone answer her for me? Please, can someone answer her for me? Do you know why we have this 1, 3, and 4 here? Michael, you want to try?
Is it representing the index?
Exactly, the index. So I said automatically this, if you don't define the index, automatically the first one in the list is 0. This is 1, this is 2, this is 3, this is 4. So as you can see, the first B is 1. That is why we have 1 here. And then we have C, which is 3. That is why we have 3 here. And then this B, that is why we have 4 here. Are you okay, Sharon?
Yes, please. Thank you very much.
Welcome. Okay. So we move on. Joining data. So basically, when we say join, we understand basically combining 2 or more things. I hope you get it. In SQL, we may say a primary key. We may define something called a primary key, secondary key, and all these ones. So in this one, we combine data from multiple tables based on a common key, the primary key in this case. So I have 2 data frames here, and I want to merge them. I have data frames of different IDs. Okay, I want to put them together as one. So let me put the code there, and then let me start from that angle for us to understand what I mean. So I hope you can see. I mentioned we have left join, right join, inner, outer. This thing data, the concepts are the same. That is why from day one I mentioned that we should understand the fundamentals. Once you understand the fundamentals, the tools wouldn't be difficult for you to learn. I hope you understand. because right join is right join, left join is left join, inner join is inner join, outer join is outer join. In SQL, in Excel too, you can perform join functions and so on. So here we have data frame 1, and this is our data frame 2, and this is our data frame. As you can see, we have repeated values or repeated IDs here, 1, 1, 2, 2, just that this one is different, okay? And merge data. So we are merging it, and then we are doing this. What is the key that we are using? You know, we are going to use Python. Get to know Power BI and those visualization tools too. The merging tools, they how do you merge by a particular common key. So over here too, we are using that we are merging based on the IDs because the IDs are common in both data sets or data frames. And how? The left. Okay. So the left means that we are looking at the things on the left columns. I hope you understand. So now, so I don't know how. Come on, let me demonstrate this. So I hope you can see my Excel. No, I don't think you can. Let me stop sharing and share my whole screen. No, let me stop sharing and do this. Can you see my Excel sheet now?
Yeah.
So we have ID, we have 1, 2, 3. Okay. And then we had name. Okay, let me use any name. I don't want to go back. Maybe Kojo Ama. And then we have another data, another ID. We have 1, 2, 4. And then that one was age. Let's say 19, 20, 30. Okay. So we are joining this data to this data. Okay. And we are using left join. So this on the, so everything here, we are trying to bring it here to add it to this particular data. Okay. Everything in this data set based on this ID. So once this and this matches, then whatever there, so the age will automatically come here. And now ID1, what is the age? 19. ID2, what is the age? What? 20. And then ID4, okay, if it is not here, is it going to appear or is not going to appear? Because, so let's see our outputs here. So that is I'm just explaining the rationale behind that. So you can see that from the outputs, okay, if you can see my Excel, we are performing a left join, okay? So 3 is not here. So there is nothing moving from here. So 3 will be empty. And now 4. 4 is here, but it's not here. So it's not going to take anything. Please, is that okay? I don't know whether you understood it well. Please, did you get what I tried to explain? Hello?
Hello.
Yeah,
Can you
but
take it again?
No, please, can you
Okay. Okay, let me go over again. So we are performing a left join. Okay, so this is the left side, this is the right side. Let me remove this. So now, when you see anything on the left, okay, that is on this left, bring the corresponding output here. Do you get me? So we have 1, 1. So the age will be what? 19. We have 2, 2. The age will be what? 20. Do we have 3 here? Hello?
No.
So here will be nothing. I hope you understand. Is
Yeah.
that clear?
Yeah.
So that is why over here you can see. So now let's change the how to inner join, and see how it's going to give us. So inner join means that it's like a circle. I mean, we did sets. I don't even know why. It's just we did sets, right? I mean, we did sets. We understand the intersection and all those things.
Yeah.
So
Yes.
basically, that is the principle we are applying here. Okay. So the inner means the intersection. Once it's in this and it's in that. So going back to Excel. 1 is here, 1 is here, 2 is here, 2 is here. So basically only these ones are going to come. It's not going to move on to this. When it moves on to this, there is no corresponding value here because this ID doesn't appear here, so it will cut there. I hope it's clear.
Yes,
So
sir.
do you
Yes,
understand?
Yes.
Okay. I move on to the next one.
Yeah.
So string manipulation, performs operation on string data such as extracting substring, replacing characters, or converting uppercase, lowercase, and so on. So using the same data sets, okay, or data frame. The merge data, we are using both data frame D1 and D2 on the same ID, and then we are going to perform a left join. Now let's see how the output is going to be like. I think basically it's going to be the same thing. Hold on, guys. Oh, it's different data sets. So in this data, this is the data. I think I made a mistake in the slides preparation. Oh, sorry. Because the right codes are not that one. The right codes are here. So let me indicate just so maybe I would have to update the slides so that manipulation. Okay. Okay, so this is the right example. So the data is equals to this, and the name, okay? Alice Smith, Johnson, Charlie Brown, and then we've stored it. So now, what we want to do is, let's assume that, this is the full name, and then we want to split the last names. You get me? So now, the data frame, we define a data frame called the last name. And how are we going to get this last name? We are getting it or we are extracting it from this name, the key here. So it's a string. We all know it's a string. Then we are going to split the string. -1 means you are going to start from the back. I hope you understand. So this is it. And then this one is for us to convert it to capital. So once we run this, you can see that the last name, it will bring the last one, all the surnames in our setting. That is why we may see the surnames. We can see. And now the upper one will just, because we are performing the upper name on the whole name, is going to, what do we call? Convert the whole thing. Assume I make this last name Let's run and see. I hope you see the change here. Can you see the changes there?
Yes, please.
Okay, so depending on what you want to do, you just need to write the codes to suit what you want to do. Yes, in these days, someone will say AI is there. You don't need to write everything. It's very true. But the truth is, if you don't understand what you are doing, you write, sorry to say, garbage, which will take you a lot of time giving you errors. So once you understand the fundamentals and you are using AI to help you to become much more efficient, it's good. But understanding the fundamentals is always key. So please, let's try to understand these fundamentals. Thank you. Do we have any question up to this point?
I please go back to me, sir.
Go back. I'm listening, please. So I mentioned that the example under this one is not the right one. I made a mistake when preparing the slides. But then the correct example is what we just did. So I want to know who said we should go back so that you can ask your question.
Like, can you do a review of what you just explained?
What I just did, okay. So what we just did, what we're trying to say is that we have names, full names here. Over here, we want to extract the last name. Okay, we want to know the last names or extract only the surnames. So for us to extract the surnames, we need to define the data frame. So we are defining a new data frame, or we want to store the last names into a new data frame. That is why when we introduce the DF, we defined it. And then which of the DFs are we gonna, or which data frame are we working on? We are working on the main data frame, which is this key. So we mentioned the key here. Okay. And then this here is a string. Remember, this is a string. So we introduce string and we split. We are going to split the string. Okay. And then how are we going to split the string? We are splitting the string from the back, meaning that we want to extract the last word or the last whatever it is, whether number, item, name. You get me? That is why we brought this -1. Okay. So when we do that and we run this is the output we are going to get. Because of the -1, it's going to detach the last names from the first name. Is that okay? Hello?
Yes, sir.
Okay. Do you have any question up to this point? Oh, please, are we enjoying?
Yes, we are enjoying it.
Oh, okay. So, why did I repeat? Sorry, I don't know why. I repeated the same example throughout. Why? This example under the date and time manipulation too is wrong. I don't know why. It's not the right one. I just need to correct that and probably update. Oh. So we are looking at how we can manipulate date and time. You know, sometimes when you are working with data, you want your data or your date format to be in a particular format. Sometimes it can be month, year, day, month, year, and so on and so forth. But then you want it to be in a particular format. I hope you understand. Or you want both of them to appear. So how do you manipulate everything? So now let's look at this example. So we have our data of, we have this data or dictionary stored in this data. So the dates, we have January 1, 2023, January 2. So now you see the issue. Now, how do we know whether this is a month or day? I hope you understand. We may not know because 01, it can be 1st January or, I mean, example, this one, it can be 1st January, 2nd January, 1st February, 2nd. I hope you understand. That kind of confusion also comes. So, but I know that by default, when you see date format like this, normally the middle one, when it's dash dash like that, the middle one is most at times the month. When we have, it can also be this way too. Let me comment here for us to see. It can also be like this. I hope you understand. Or even the date can be like this. You get it? So now, what do we want to do? We want to convert the date column to date time objects. Okay? Now, this is the dates. We want to convert it to date time. Let me comment this one. Let's run the code and see how we get. Let me uncomment this one. Okay, sorry. So now what we want to do here is after we've done this conversion, okay, we want to extract the year and month. Assume we are confused, as I am confused. We don't know which one is the month, we don't know which one is the day. Okay. How do we know? With this code. So now we want to extract the year from the dates. So we define this data frame. Okay. What do we want? We want the year. And what are we working on? We are working on these dates. Okay, the key here in this particular dictionary that we've stored in this data or in this variable called data. So dt, okay, is date time dot year. We are specifying that we want to what? Extract the year from it. So this will give us the column name, okay, and then this is going to give us our value. The value that we want is the year. So this is going to give us the column name. So we need to define the column name, okay, in the data frame. From this column name or this key over here, the key is here. And then the dt is date time, as I said. And what is the value that we want, the month? So once we run this, code, we will know that for the year is obvious. And the months, now we were confused as to whether is this the month or that is the month. But with this one, we are now able to tell, okay, so the middle ones are the months. So January is what we are talking about. Please, is that okay?
Yes, please.
Did we get the explanation? Hello, did we get the explanation? Okay. Okay, thank you. Now, handling the same values. Let me check the data cleaning parts. If we are going to do on the same values there, yeah, we are going to do it here. So then let's count it. Because the last thing we are going to do here, we're actually going to repeat. So let me handle it over here so that it will be easier. Do we have question? Actually, this is the last thing we are looking at for our week 2. I hope we can finish it in the next 40 minutes. Do we have questions up to this point, please? Oh, we are not talking. Oh, are you okay? Okay, so it's either we are confused, we don't understand anything, Yeah, okay, you understand everything, which is which. Hello, please, I want to hear feedback.
Can go on, sir.
Yes, sir, you can move on.
Sandy, what's up?
Yes, sir. Thank you very much. For me, I think I'm following all right. But when the class is over and you have access to the recordings, probably when I go through, I'll be able to take my time and move at a pace where things will be much more clear. If I have any difficulty, I'll surely let you know, please.
Okay, sure. So, as I promised, I'll try and upload them by close of day tomorrow, okay? I'll try and upload them by close of day tomorrow. So that we can have Tuesday, Wednesday, Thursday, Friday at least to go through before our next meeting. Our next meeting, we are going to apply this principle and then we continue with how we can visualize data using some libraries in Python. Okay. So we just have 2 weeks more and this whole thing will be over. So let's try as much as possible to understand what we're doing here. So data cleaning. So basically when we say we are cleaning data means that we are trying to work on the data in a way that it will be satisfying or in a way that the final data set will make sense. I hope you understand. So it involves identifying and correcting errors, removing every inconsistency and inaccuracy in the data sets. So as I said earlier, in the real world, you will always get inconsistent, incomplete, messy data sets, and that is the headache. You get me? So for a powerful machine learning algorithm to work, it means that the data that the model was trained on was a complete, a consistent, a cleaned data set. Pre-processing means that we are transforming the data into a suitable format for analysis or for modeling. Why do we need to do this in the first place? One, so that there will be an improved data quality, okay? I mean, why data cleaning is important is for us to get improved data. Once the data is accurate, it improves the trust. Assuming you built a model to predict whether or not someone has malaria and your data set is not accurate, will you trust the model? I'm asking a question. Will you trust your predictions?
No.
No, please.
Yes. So a clean data ensures that or builds trust. You get it? Okay. And then it enhances model performance. So as I already said, the prediction accuracy is trusted. And then it reduces bias because the data is not skewed towards a particular direction. Yes, sometimes you can clean data, still it will have imbalance. That one we will look at it. I mean, well, we may not go into that, but maybe in the intermediates, they are going to look at that, where you address data imbalances when you are training models. Because if you don't clear and work on the imbalance, it's going to affect the performance of your model. And better insights, you're able to trust the analysis that you are doing. Now, because our data is not complete and is inconsistent, definitely we are going to see errors. We are going to see missing values. I hope you understand. Now let's do this together. I want us to download these data sets. Actually, oh, what is this thing? I hope you can see my screen. Can you see my screen?
Yes, please.
Yes, sir.
Okay.
Yes, sir.
Yes, please.
Okay. So I'm downloading this CSV file for a trade data in Liberia. Okay. That's not download. Oh, okay. So I'm coming here. Okay. So import pandas as PD. Import. Okay. And then should I make it? So I mentioned that you copy the path, you come here and then what? You 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 paste it there. I want to introduce something. Oh, oh, okay. So I have inputted this data. The head here is to automatically, when you bring head, is to see the top rows. If you bring head without specifying the number, automatically it gives you the top 5 rows. You get me? So now we see that this is the data set. We have in this data set, we have the date column, we have the type, we have the description, the name of the exporter, importer, declarant name, origin, country, HS code, a whole lot of columns. I hope you understand. Now, I want us to look at this. How we are going to visualize the missing, because for you to work on the missing values, you need to know how to where the missing values are. So I want us to do this. So I'm introducing to this library, import. We are not going to do matplots here now. We are going to import missing. There is a library, missing NO as MSNO. It's a library. Okay. That will help you visualize how your data is looking at. It's looking like. Okay. Sorry, I need to run this. I didn't run this. One thing about Colab is whenever you add something, you need to run that part again, or probably you can add it here like this. Import this, and then you run it, okay? Both are okay. Okay, now this data is structured. It wouldn't serve the purpose I want. So as you come to this data, I hope you can see the screen I've switched to. The breaking here, you see there are white lines. Okay, horizontal breakages. I hope you can see.
Yes, please.
So all those breakages are telling us that these places there are issues. Where there are breakages, there are issues. But the data I downloaded, actually there is no issue. I need to get the data that has issues. This data, everything is okay. It doesn't have any issue. But you can see that this data, it has issues. All the horizontal breakages. Please, I hope you can see it. It means that there are issues that need to be resolved in there. However, this Python library, the MSNO or MSNO, is a way for you to visualize your data set to get holistic view. But this one, there are no breakages. There are no horizontal lines. So maybe I may get another data. Let's continue. So with this one, I'm just going to talk about them. Sometimes you can drop those rows and columns. You get it. So in this one, let me copy this. Let me bring the code so that guys, so then I'm coming with this. Because I wanted us to work with raw data sets so that we will understand. I'll get some data sets from my laptop, but let me explain this first, and we continue from then. Okay, so now can you see my screen? Hello?
Yes.
Yes.
Hello. You can see the screen.
So we can see that in the first one, column 1 has this 1, 2, 9, and 4. Okay. Column 2 has 5, 9, 7, 8. We've stored these data sets, including the missing values, into this data frame. Now, one way you can handle missing values is by dropping them. Okay. How do we drop them? You introduce the drop NA, not available. Do you get it? That is the drop NA. So once you drop them, any missing values together with the rows and columns will go away. And now you get a new data set, which in this case, they defined as cleaned, df underscore cleaned. You get it? df underscore cleaned. So let me get a data set from guys, can you see my screen?
Yes, please.
Okay. So I want us to work with real world data sets. So now I'm running this, okay, and then let me visualize this. I'm hoping this one is not structured. Oh, I need to get another data set. I'm coming. Let me check this diabetes data set and see.
Hello.
Hello.
Yes, sir. Please have a question.
Okay.
Yes, so please, when it comes to data cleaning, when you drop like when you drop the other values, won't it affect the data set? Maybe you won't it affect the overall data quality?
Yes, it can. So it's one. So there are different ways. So it's one way. Sometimes dropping them. So one, what I would say is the domain knowledge is very important. You
Okay,
understand?
okay,
Because sometimes when you drop them, it wouldn't affect the main purpose. And
okay,
as you said, sometimes too, when you drop them, it will affect. So that one, to the other ways we can tackle that. So we are going to look at that shortly. I hope we can.
thank you.
Welcome. Uh, I just want to get a data set that is not structured, so we can work with that. Unfortunately, I don't know why. Oh, which one is this? Let me get data set. Maybe this one is. I'm hoping I get. Maybe let's try the Mali data and see. I want a data set that is not structured. At least can see some missing values. Uh, I'm sure this data set will have issues, so let me download this one. There's the download button. Oh, no, I couldn't get. So let me download the CSV. I'm sure this one will have issues. Let me download the CSV. Okay. Please, I hope you are still here. I'm just working on getting a data set we can actually perform this drop stuff on it. Uh, okay. Um, okay. Good. So we have something like this. I hope you understand. Okay. So one way for us to deal with this is, let's say, do you have plain data? You get it. So the first code, let me do it one after the other. We do this, and then now let's visualize it again. You can see that it has removed, you see the last review, okay, it has removed, you see there were a lot of breakages here, so it has removed all those breakages or all those missing values. I hope you understand. So after we perform that, look at it now. We have a very structured data now. This is that okay? Hello?
Yes, please.
Yes, sir.
Okay. And then the other way where I said is that is why I mean the reason why I said is the reason why I said that dropping sometimes also has impact is because sometimes when you delete them it has huge impact on your data depending on what you want to do. So domain knowledge is very important. Sometimes you can use the mean, you can use the median and the mode just to um, fill in those gaps. Assuming you are working on maybe a marketing data or house pricing, we know that maybe for a standard three-bedroom house in, let's say, Accra, this is the cost. So in a particular row or in a particular column, maybe the cost for a particular house is missing. If you are a real estate guru or you know someone, you can say maybe I'm working on this project. There is this particular house located in, let's say, Medina. Um, I don't know the price. Can you help me? So with that knowledge, okay, you can know that or based on your research, you know that the average prices sold in that area is let's say 20,000 cities or $20,000. So based on that, you can use $20,000 as the price without necessarily dropping it. I hope you understand.
Yes, sir.
Yes.
Do you get it? So sometimes you can use the median. Okay, the mode. Okay, normally the highest is normally is this. So you can use the mode, you can use the median. So it depends on these ones for you to use the median, the mode, and then whatever. The domain knowledge or domain expertise is very, very important. If not to, you may use an overly I mean too much value or probably a value that is way, way below what is required in the industry. I hope it's clear. So that is another way you can handle missing data. This is that okay? Hello? Hello? Are you there?
Hi.
Yep. So
Yes, we are
that
here.
is another way we can handle missing data. Okay. So we can move on. Hold on, guys. Okay, so we can also use the k-nearest imputation. So that one to replacing value with the average k-nearest neighbor. Consider the relationship between variables. So now, in this example that we are seeing here, okay, we have column ones and then this column. And then the KNN imputer, sorry, the nearest neighbor, we are going to use 2. Okay, so now let's run this and let me explain the output to you for you to understand. Um, um, okay. So, so we have these data sets. Okay, we have these data sets, and then we one we have column 1 and then column 2. Okay, And then column 1, we have 5. Column 2, we have 6.5. But in the original thing, in column 2, the second value is missing. I hope you understand. It's none here in the original data set. And then in column 3, in column 1, the third value is also missing. I hope you understand. And that way. So what we want to do is the nearest neighbor, or the k nearest KNN, means we are using a particular a nearest neighbor. Which example should I even use? So assuming that maybe, yes, so if you look at 2 here, okay, 1 is mapped to 5. Assuming, I'm just using this as an example. 1 is mapped to 5. I hope you understand. Okay. And then if you look at this, okay, yes, this was missing, but the next column was 7. And then we have 8. So for us to replace this, and then using this column as a reference, okay, this column as reference, the column that we want to replace is actually the number that we want to replace is actually this in the first instance. So between 5 and 7, okay, between 5 and 7, we can say that the calculation, actually there's a mathematical calculation behind this, but the general knowledge is between these particular neighbors, how do we fix these missing values between these particular neighbors? So we are going to get a number that is kind of close to 7 and 5 in this particular instance. I hope you understand. So it does that calculation. That is how come we got 6.5, even though originally it was none. But over here, we were able to get 6.5 as a value here, because the nearest neighbor is 5 and 7. And then we need something that is between or close to their nearest neighbors. I hope you understand. And then in the same vein here too, we have 2 and 4, and this is missing. Okay, so we want a neighbor that is between 2 and 4. Okay, because these are their nearest neighbors, or this particular thing, these are its nearest neighbors. That is why after their calculation, it gave us 2.5 here. Please, is that okay? Hello?
Yes, sir.
So that is the concept, but most of the times, well, in most of the works I've done, I've actually not used this nearest neighbor. I'm not saying you don't use it, but some of these concepts are rarely used, but it's also necessary that we know. You get it. Okay, so the regression imputation, that one you use a regression model based on that one is another way you can actually replace. But what is mostly used is either people will drop them or use the median, the mode average computations. You get it. So now let's move on to how we can handle outliers. When we talk about outliers, we are talking about data that is way above the normal. I hope you understand. That is basically what outliers mean. Way above the normal or below the normal. Do you get it? So in this example, okay, in this example, we are looking at the data set has this dictionary, okay, we have this column in their value. So this, we have 1, 2, 3 up to 9, and then there, instead of 10 or something, it jumps to 100. You see, 100 is way, 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 way above. I hope you understand. It's way, 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 way above. So how do we detect these outliers? We can actually use regression methods or like kind of visualize them just to see how our data is. You get it? We are going to treat visualization next week, but I just want to mention it. So in this example, I may not explain the visualization, but I just want you to see how you can also identify missing data using visualization. But next week, we are going to go into details in visualization. So when I run this, you can see that all the data is within this range, but we have one that is well separated. I hope you understand. So there is one way you can visualize outliers or visualize data to detect outliers and how we are going to look at how you can deal with these outliers. Please, is that okay?
Yes, sir.
Sometimes too, you can use the interquartile range to do it in working or handling these outliers. Okay. So you know the percentiles, the 75th, the 25th, and all those ones. So based on, let's say, industry domain or domain expert knowledge, you're able to calculate and know the best percentiles to use in order to kind of minimize these outliers. Please, I hope that is okay. So there is also another way. So in this example, K1 is coming. Let me just do this so we can. Okay. So what is here is K1. Okay, the data frame is equal to. So we are still working on this data frame. Okay. This quartile, we are looking at the 25th quartile, percentile. And then, here 25% and there's 75%. Then the interquartile ranges, the Q3 minus, we subtract the Q1 from the Q3. Okay. So it's more like statistics. Okay. And then for us to identify the outliers. Okay. Now, if we multiply 1.5 by the interquartile range, okay, and it is greater than the column 1, then it is an outlier. Or if the column 1 is greater than Q3, which is the 75th percentile plus 1.5 times the interquartile range, then that one too is an outlier. That is how we were able to see that, okay, 102 is an outlier. I hope you understand. The 9 here, it means, I hope by now we understand why this 9 is here. It's just the index. Okay, so the interquartile range is another way for us to identify outliers. But I think the easiest one is the visualization. Because with the interquartile range, if you don't understand statistics and you make a mistake, you may get values which may actually not be outliers, but because your calculations are wrong, it may appear to be outlier. Okay, so data pre-processing. I would want to end here. Next week we'll look at this whole thing because it's probably I'm looking for different examples to explain this thing. I wanted us to look at this thing when we are doing them, but we'll see how it goes next week. We'll look at this thing next week. Okay. Do you have any question? so far?
No, please, no question so far.
Do you have any questions so far? Okay, wisdom.
Okay, sir. I don't really have a question about the studies today, but the assignment that was given, some of us couldn't come to the room early, so we're not able to get the briefing on it. Please, can you go over for it?
Okay, so for the assignment, the whole thing, for you to get it, you would have to watch the video, which I will upload. However, basically what I want you to do is about how you can import and read data. Okay, and I'm going to add another one based on what you did today. So we've spoken about the mean, we've spoken about the mode and all those things. So I will maybe tomorrow I will probably do an example, if not tomorrow, maybe Tuesday or within the week, but before next week. And then for you to see what I want you to do in the week too. Okay. For the assignment one, I'm going to upload the video actually, so you can go over. But basically, as we did here, how to import data, and then you explore the data. So maybe you can let me know maybe the top 5 rows, how it looks like the last 5 rows. If you want to look at the last 5 rows or the last whatever rows, maybe this I can look at 10. Okay. So D10, so actually give me the top 10 rows, which I mean, if I want to look at the bottom, I just change the head to tail, and that one will give me the bottom 10. However, if I don't define any number here, this is going to give me just the bottom 5, the last 5. I hope that is clear. So I just want you to kind of do in the first assignment something like this. So when you are submitting, you submit your what do we call your color file together with your data set. And then for the assignment 2, I am going to give an example, probably document something and upload, so that based on that, you can use the same data sets that you use for the assignment 1 to do the assignment 2. And actually, you can also do it in the same Google Sheets or Collab Sheets. I hope you understand. You just need to specify which is assignment 1 and assignment 2. Please, is that okay?
Yes, sir.
Yeah, tomorrow, the reason I'm saying Tuesday is tomorrow I have a busy schedule. That is why. So if Tuesday by noon, I have not said it, kindly remind me. I'm also kind of, I know we are all busy, we are working here, and then some of us are students, so just remind me because me too, I'm also kind of working on something too. So, but I'll make sure I don't forget that if by Tuesday noon I have not done anything or said anything about the assignment, to kindly remind me in the group. Is that is clear?
Yes, sir.
Okay. So I'm going to stop here.